Welcome to the video on trig derivatives and integrals and partial fractions. So here we have several trigonometry derivatives. So if we take the derivative of tangent, we'll get secant squared of x. The derivative of secant of x is secant of x times tangent of x. The derivative of cosecant of x is negative cosecant of x times cotangent of x. The derivative of cotangent of x is negative cosecant squared of x. The derivative of a to the x is a to the x ln of a. The derivative of log base a of x is 1 over x times the natural log of a. The derivative of arcsine of x is 1 over the square root of 1 minus x squared. The derivative of arccosine of x is negative 1 over the square root of 1 minus x squared. And the derivative of arctangent of x is 1 over 1 plus x squared. So all of these things are derivatives to memorize. So there are quite a few here, so you might want to make flashcards or something like that to memorize all of these. So next we have our trigonometry integrals, which are basically our derivatives, but flipped. So we have our integral of secant squared of x dx is tangent of x plus c. The integral of secant of x times tangent of x is secant of x plus c. The integral of negative cosecant of x cotangent of x is cosecant of x plus c. The integral of negative cosecant squared of x is cotangent of x plus c. The integral of a to the x ln of a is a to the x plus c. The integral of 1 over x ln of a is log base a of x plus c. The integral of 1 over the square root of a squared minus x squared is your arcsine of x over a plus c. So this time we have the a added in. Our integral of negative 1 over the square root of a squared minus x squared is our arccosine of x over a plus c. And then our integral of 1 over a squared plus x squared is 1 over a times arctangent of x over a plus c. So if we have any of these integrals and it's a composite function with a linear function, so if we had secant squared of x, for example, but instead of that it was secant squared of 3x plus 5, and we were taking the integral of that, then our integral of that will equal 1 over a times the normal integral, except that x will be ax plus b. So our integral of secant squared of x dx was tangent of x plus c. So our integral of secant squared of 3x plus 5 dx will be 1 over this a value, so 1 over 3 times the normal integral of that, so tangent of x. But instead of x, we'll have our 3x plus 5, and then we have our plus c. Next is using partial fractions to find integrals. So when you're given a function with a quadratic in the denominator, partial fractions can be used to split the function into the sum of two functions with linear equations in the denominators. So if you had some number in the numerator and two linear functions in the denominator, so if you factored the denominator from being a quadratic, then you could split it into the integral of one of them plus a number on top plus the integral of another plus a number on top, which we talked about partial fractions in a previous video and how to solve for what capital A and capital B are. So when you take the integral of that, you'll get capital A over lowercase a times the natural log of the absolute value of ax plus b plus capital B over lowercase c times the natural log of the absolute value of cx plus d, and then you can't forget your constant at the end. So for this example, it says find the integral of 1 over x squared plus 3x plus 2 dx. So we have a quadratic in the denominator. So first we're going to split this 1 over x squared plus 3x plus 2 into two fractions. So we can factor x squared plus 3x plus 2, and it's going to be x plus 2, x plus 1. So we're going to split that into a over x plus 2 plus b over x plus 1. So to solve for a and b, we'll multiply everything by x plus 2 times x plus 1. So our left side of the equation would just become 1. And then our x plus 2 in the denominator will cancel with an x plus 2, so we'll get a times x plus 1. And then underneath our b, we have an x plus 1, which will cancel with the x plus 1, so we'll just have b times x plus 2. So to solve for a and b, we want to set one of these factors to 0. So we could plug in -1 or -2. So we can go ahead and say when x equals -1, then we'll have 1 equals a times -1 plus 1 plus b times -1 plus 2. So -1 plus 1 is 0, so this whole term will go away. So we get 1 equals b times 1. So 1 equals b. So now that we know b equals 1, we have 1 equals a times x plus 1 plus b, which was 1, times x plus 2. So we'll plug in another value for x. So when x equals 0, for example, we would get 1 equals a times 0 plus 1, which is 1, plus 0 plus 2, which is 2. We'll subtract 2 from both sides to get that -1 equals a. So we can rewrite this integral as the integral of this here. So a over x plus 2, which is -1 over x plus 2, dx plus our integral of b, which was 1, over x plus 1 dx. So this is easier because we just have linear equations in the denominator. So our integral of -1 over x plus 2, we can pull the negative out front, and the derivative of 1 over x plus 2 is the natural log of the absolute value of x plus 2. And then we have plus the integral of 1 over x plus 1, so that's the natural log of the absolute value of x plus 1. And then we don't want to forget our plus c. We can combine our natural logs, so we'd have the natural log of the absolute value. We would put x plus 1 in the numerator because it's a positive natural log, and the other one is a negative natural log, so we'll put x plus 2 in the denominator. So this would be our solution to that. So here we have our first IB practice question. It says, find the integral of 14 over x squared plus 3x minus 10 dx. So we have a quadratic in the denominator, so we can try using partial fractions. So we have 14 over x squared plus 3x minus 10. You can factor the denominator, so this becomes 14 over x plus 5 times x minus 2. So that'll equal a over x plus 5 plus b over x minus 2. When we multiply everything times x plus 5 times x minus 2, you get that 14 equals a times x minus 2 plus b times x plus 5. So if x equals 2, we'll have that 14 equals a times 2 minus 2, so we're zeroing that one out, plus b times 2 plus 5. So this would be 0. So 14 equals 7b. When we divide by 7, we get that b equals 2. So 14 equals a times x minus 2 plus b, which is 2 times x plus 5. Then we can try plugging in something like 0 for x. So if x equals 0, then we have 14 equals a times 0 minus 2 plus 2 times 0 plus 5. So 14 equals negative 2a plus 10. Then if we subtract 10, we get 4 equals negative 2a. And then when we divide by negative 2, we get that a equals negative 2. So we can rewrite our integral now. We have the integral of a over x plus 5, so negative 2 over x plus 5, dx, plus the integral of b, which was positive 2, over x minus 2, dx. We can pull our constant out front, so we have negative 2, and then the integral of 1 over x plus 5, which is the natural log of the absolute value of x plus 5, plus, we'll pull our 2 out front, and then we'll get our integral of 1 over x minus 2, which is the natural log of the absolute value of x minus 2, plus c. We can pull the 2 out front, so we have 2 times negative natural log of the absolute value of x plus 5, plus the natural log of the absolute value of x minus 2, plus c. Then we can combine our natural logs, so we'll have 2 times the natural log of the absolute value. Our positive one will go in the numerator, and our negative one in the denominator, plus c. So this is the solution to that problem. Now we have our second IB practice question. It says, find the following integrals. So we have the integral of 5 to the x ln of 5 dx. So we can recognize this as the integral of a to the x ln of a dx. And we should have that memorized, and that'll equal a to the x plus c. So in this case, our a value is 5, so our answer is 5 to the x plus c. For b, it says the integral of 1 over the square root of 4 minus x squared dx. So we should be able to recognize this as our arc sine. So this would be the arc sine of x over a. So it's going to be x over, our a value is the square root of this. So that would be 2. And then you can't forget your plus c. Finally, we have the integral of 1 over 2x minus 3 squared plus 9 dx. So we have some value squared plus another value squared. So this is 3 squared. So this is our arctangent function. So we have arctangent, and it's going to be 1 over a times the arctangent of x over a plus c. So this equals 1 over a. So our a value here is 3, and our x value in this case is actually 2x minus 3. So we have a linear function inside of our function. So this is arctangent. Our 1 over a would be 1 over 3. Our x here is 2x minus 3 over our a value, which is 3. And then since we had a composite function, we need to do 1 over the value in front of our x times that. So it's going to be 1 over 2 times all of that plus c. So this equals 1/6 arctangent 2x minus 3 over 3 plus c. And that's it for this question. So in summary, we have a table of derivatives to memorize and a table of integrals to memorize. When an integral is a composite function with a linear function, like if you have the integral of f of a of x plus b dx, your integral is going to be 1 over a times the normal integral where you're putting in ax plus b for your x value. For integration with partial fractions, your partial fractions can be used to split a large fraction into the sum of 2 smaller fractions with a linear equation in the denominators. So this shows how that would be done. And that's all for this video. Thank you for watching.